Data integration, at its core, is the process of combining data from disparate sources to create a unified view or dataset that can be leveraged for analysis, reporting, and decision-making. In an era where organizations generate and collect vast amounts of data from a multitude of channels, ranging from internal databases and legacy systems to cloud-based applications, social media, IoT devices, and partner networks, the need to bring all this information together has never been more critical. The ability to seamlessly integrate data not only empowers organizations to harness the full potential of their information assets, but also drives operational efficiency, innovation, and competitive advantage. The journey toward effective data integration often begins with recognizing the diversity of data sources and formats within an organization. Traditional enterprises may still rely heavily on structured data stored in relational databases, while modern digital businesses increasingly interact with unstructured or semi-structured data such as emails, images, videos, and sensor logs. Data may reside on premises, in the cloud, or across hybrid environments, further complicating the integration landscape. Each source may have its own schema, naming conventions, data types, and quality standards, making it challenging to achieve a consistent and accurate consolidated dataset. One of the fundamental challenges in data integration is data heterogeneity. Different systems are often designed independently, leading to variations in how information is represented and stored. For example, customer data in a CRM system might use different field names or formats than those in a billing system. Integrating these requires careful mapping, transformation, and sometimes even data cleansing to ensure that the unified dataset is both accurate and meaningful. This process, known as data transformation, involves converting data from its original format into a common structure suitable for analysis. Techniques such as extract, transform, load, ETL, have become standard practices, enabling organizations to pull data from multiple sources, apply necessary transformations, and load it into a centralized repository like a data warehouse. Beyond technical complexities, data integration also raises important questions around data governance, security, and privacy. As data flows across systems and boundaries, ensuring that sensitive information is protected and regulatory requirements are met becomes paramount. Effective data integration strategies must incorporate robust access controls, encryption, auditing, and compliance mechanisms to safeguard data throughout its life cycle. Additionally, organizations must establish clear data ownership and stewardship roles to maintain accountability and trust in the integrated dataset. The benefits of successful data integration are manifold. By breaking down silos and providing a holistic view of business operations, organizations can gain deeper insights into customer behavior, market trends, and operational performance. Integrated data enables advanced analytics, machine learning, and artificial intelligence applications, unlocking new opportunities for innovation and growth. For instance, retailers can combine sales data from physical stores and e-commerce platforms with social media sentiment analysis to optimize inventory management and marketing campaigns. Healthcare providers can integrate patient records, diagnostic images, and wearable device data to deliver more personalized and effective care. Modern data integration approaches have evolved to address the growing scale, complexity, and velocity of data. While traditional ETL processes remain relevant, newer paradigms such as extract, load, transform, ELT, data virtualization, and real-time streaming integration have emerged. ELT takes advantage of the processing power of modern data warehouses by loading raw data first and then applying transformations within the target system. Data virtualization allows users to access and query data from multiple sources in real time without physically moving or copying it, reducing latency and storage costs. Real-time data integration leverages event-driven architectures and streaming platforms like Apache Kafka to enable instant processing and analysis of data as it arrives. Cloud computing has further transformed the data integration landscape by offering scalable, flexible, and cost-effective tools and services. Cloud-based integration platforms as a service, IPaaS, provide pre-built connectors, workflow automation, and monitoring capabilities that simplify the integration of diverse cloud and on-premises applications. These platforms support a wide range of integration patterns, including batch processing, real-time synchronization, and API-based connectivity, allowing organizations to adapt to changing business needs and technology environments. Despite technological advancements, successful data integration is not solely a matter of deploying the right tools. It requires a strategic approach that aligns with organizational goals, processes, and culture. Stakeholder engagement is critical to identify the most valuable data assets, define integration requirements, and prioritize use cases. Data quality management must be an integral part of the integration process, with continuous monitoring and remediation to address issues such as duplicates, inconsistencies, or missing values. Documentation and metadata management play a vital role in ensuring transparency, traceability, and reusability of integrated data assets. The rise of big data and analytics has placed even greater emphasis on scalable and agile data integration solutions. Organizations are dealing with petabytes of data generated at high velocity from sources such as sensors, mobile devices, and online transactions. Traditional batch-oriented integration methods may struggle to keep pace with these demands, necessitating the adoption of streaming and micro-batch processing techniques. Open-source technologies like Apache NiFi, Talend, and Pentaho have gained popularity for their flexibility and extensibility in handling diverse integration scenarios. In parallel, the proliferation of APIs and microservices architectures has shifted the focus toward API-led integration. By exposing data and functionality through well-defined interfaces, organizations can enable seamless interoperability between systems, accelerate development cycles, and foster innovation ecosystems. API management platforms provide capabilities for authentication, rate limiting, monitoring, and versioning, ensuring that data integration remains secure, scalable, and manageable. Data integration also plays a pivotal role in enabling digital transformation initiatives. As organizations embrace cloud migration, modernization of legacy systems, and adoption of emerging technologies such as artificial intelligence and Internet of Things, the ability to integrate data across heterogeneous environments becomes a key success factor. Integration facilitates the creation of 360-degree views of customers, products, and operations, empowering businesses to deliver personalized experiences, optimize processes, and respond swiftly to market changes. Furthermore, data integration supports regulatory compliance and risk management. Regulations such as GDPR, HIPAA, and CCPA impose strict requirements on data handling, consent, and transparency. Integrated data platforms enable organizations to track and manage personal data across systems, implement data subject rights, and demonstrate compliance through comprehensive reporting and auditing capabilities. The human dimension of data integration should not be overlooked. Successful projects require collaboration between IT, business units, data stewards, and end users. Change management, training, and communication are essential to ensure that stakeholders understand the value of integrated data, adopt new processes, and trust the outcomes. Organizational culture must encourage data sharing, experimentation, and continuous improvement to realize the full benefits of integration. Looking ahead, the future of data integration will be shaped by emerging trends such as automation, machine learning, and self-service capabilities. Intelligent data integration tools are leveraging artificial intelligence to automate tasks such as data mapping, schema matching, and anomaly detection, reducing manual effort and accelerating time to value. Self-service integration empowers business users to connect, transform, and analyze data without deep technical expertise, democratizing access to insights and fostering a data-driven culture. Another area of innovation is the integration of data across organizational boundaries, enabling collaboration and value creation in ecosystems and supply chains. Technologies such as blockchain and secure data sharing platforms are being explored to facilitate trusted, auditable, and privacy-preserving data exchanges between partners, customers, and regulators. In conclusion, data integration is a foundational capability for modern organizations seeking to thrive in a data-driven world. It bridges the gap between fragmented data sources, unlocks the power of analytics, and supports strategic objectives across industries and domains. While the journey is complex and multifaceted, combining the right technologies, processes, and people can transform raw data into actionable intelligence and sustainable business value. As data continues to grow in volume, variety, and importance, the art and science of data integration will remain at the forefront of digital innovation and organizational success.